There is a place in the Baltic Sea, a gray stretch of cold water sitting between the coastlines of Denmark and Germany, where something almost unimaginable is happening beneath the surface. Engineers are not merely building a bridge, they are not simply laying cable, they are constructing an immersed tunnel, the longest of its kind ever attempted on this planet, by manufacturing colossal concrete structures on land, floating them across open water like the world's heaviest ships, and then deliberately sinking them to the seabed, one by one, until a continuous underwater highway stretches 4 kilometers below the waves, connecting 2 nations and reshaping the economic geography of an entire continent. This is the Fehmarn Belt Fixed Link, and when it opens, nothing about how Europe moves will ever be the same again. To understand why this project exists, you need to understand the frustration it is designed to end. For decades, traveling between Scandinavia and Central Europe by land has meant one of 2 things: either a long detour through the congested Øresund Bridge connecting Denmark to Sweden, and then down through the Jutland Peninsula, adding hundreds of kilometers to every journey, or a ferry crossing between the German island of Fehmarn and the Danish island of Lolland. That ferry, operated for generations across a belt of water just 18 kilometers wide, carries millions of passengers and tens of thousands of trucks every single year. It is a bottleneck at the heart of Europe's most important north-south corridor, a gap in the map that costs the continent billions in lost time, wasted fuel, and throttled trade. The solution, dreamed about for half a century and finally approved after years of political negotiation, environmental study, and engineering debate, is a fixed link that will allow a car to travel from Copenhagen to Hamburg in 2.5 hours, a journey that once took 4.5. A train carrying freight from Stockholm to Central Europe will no longer need to stop, load onto a vessel, cross open water, and reload onto tracks on the other side. It will simply travel, continuously, smoothly, without interruption, through a tube at the bottom of the sea. The scale of this undertaking is so vast that ordinary measurements struggle to contain it. The tunnel will stretch 18.2 kilometers from shore to shore, making it the longest combined road and rail immersed tunnel ever built. It will carry 4 lanes of motorway traffic and 2 electrified railway tracks simultaneously. And it will be built not by drilling through solid rock or digging into an existing seabed, but by manufacturing enormous hollow concrete elements on land and assembling them underwater like the most consequential jigsaw puzzle in engineering history. The construction begins not in the water, but on the island of Lolland in Denmark, where engineers have built what can only be described as a factory the size of a small town. This facility, covering more than 40 hectares of reclaimed land, is where the tunnel itself is born. Inside its vast production halls, workers pour concrete into enormous steel molds. The mixture used is not ordinary concrete. It is a precisely engineered formula designed to resist the relentless pressure of Baltic seawater for at least 100 years, resistant to chloride penetration, resistant to the microscopic chemical attacks that saltwater wages on conventional materials over time. Every batch is tested, every pour is monitored, because a flaw invisible to the naked eye today could become a fracture under thousands of tons of water pressure tomorrow. Each standard element that emerges from this factory is 217 meters long. Let that settle for a moment. 217 meters, roughly the length of 2 football pitches laid end to end. Each one stands 9 meters tall. It weighs approximately 73,000 tons. To give that a sense of physical reality, consider that the Eiffel Tower weighs approximately 7,300 tons. A single tunnel element weighs 10 times that. These are not components, these are structures, buildings laid on their side, hollow through the middle,
sealed at each end with steel bulkheads and designed for one purpose: to be floated out into the Baltic Sea and placed on the bottom with a precision measured in centimeters. The factory produces these elements one after another in a continuous industrial rhythm. Reinforcing steel is bent and positioned first, thousands of tons of rebar woven into precise geometries that will give the concrete its tensile strength, its ability to resist not just compression, but the bending and flexing forces that come from being handled, towed, and positioned in open water. The concrete is then poured in carefully controlled lifts, layer after layer, curing under controlled conditions before the next section is added. The sheer choreography of this process, the scheduling, the material flows, the quality inspections, the curing times, represents one of the most complex logistical operations in European construction history. Once an element is complete, it is floated out of the production facility using a controlled flooding technique. The dry dock that connects the factory to the sea is flooded, water lifting the sealed concrete element from its construction cradle. For the first time, something that weighs more than most warships floats on the surface of the Baltic. Specialized pontoons and tugs take control. The element is towed carefully to its target position, guided by GPS systems of extraordinary accuracy, because the margin for error in placing a 200-meter tunnel section on a prepared seabed trench is not measured in meters, it is measured in fractions of one. The seabed itself has been prepared to receive these elements. Dredgers have carved a trench along the alignment of the tunnel, cutting through the soft sediments of the Baltic floor, encountering everything from sand to ancient clay deposited during the last ice age. The prepared bed is layered with a gravel foundation, leveled to millimeter tolerances by remotely operated equipment working in water up to 40 meters deep. Then, when the element arrives at its position above the trench, the real precision begins. Water is carefully admitted into ballast tanks built into the element, reducing its buoyancy in controlled increments. The element descends, slowly, deliberately, under the continuous direction of survey teams monitoring its position in 3 dimensions simultaneously. As it approaches the previously placed element, rubber gaskets at each end compress under the approaching weight, forming a watertight seal with a force that no pump or bolt could match. Just the crushing, irresistible weight of tens of thousands of tons of concrete pressing forward. The water between the 2 elements is then pumped out, and the sea pressure outside locks the connection with a grip that will hold for a century. This process will be repeated 89 times, 89 elements, plus 10 special units for the service tunnels and cross passages, lowered and connected in sequence across 18 kilometers of Baltic seabed. The civil engineering alone is staggering, but the full scope of the project extends far beyond the tunnel mouth. On the Danish side, entirely new motorway and railway connections are being built across the island of Lowland to integrate the tunnel with the national network. On the German side, the existing railway line running north through Schleswig-Holstein requires significant upgrading to handle the increased traffic volumes the tunnel will generate. The total investment, tunnel, portals, land connections, and upgrades runs to approximately 10 billion euros, a figure funded through a combination of Danish state loans, European Union support, and the tolls and fees the tunnel will collect for the decades it operates. And operate it will, at a scale that transforms the economics of this entire region. The tunnel is projected to carry approximately 12,000 vehicles per day in its opening years, numbers that will grow as the reliability and speed of the crossing draw traffic away from the longer ferry and road alternatives. Freight operators for whom time and predictability are measured in profit margins will route shipments through this corridor rather than the detours they navigate today. The European Union's ambition to shift freight from road to rail gains a critical new artery. The cities along the corridor, Hamburg, Copenhagen, Malmö, Stockholm, draw closer together, not just in distance, but in economic integration. There is something deeper here, too, beyond the logistics spreadsheets and the engineering specifications. The Fehmarn Gulf Tunnel is an act of continental ambition. It is the physical embodiment of the idea that the nations of Europe, bound by shared interests and connected by shared infrastructure, can undertake works that no single country could accomplish alone. That the same determination which once built cathedrals rising above medieval skylines and railways crossing impossible mountain ranges is alive today, expressed not in stone spires and iron viaducts, but in hollow concrete tubes sinking silently to the floor of the Baltic. When the last element is placed, when the water is pumped out, and the inspection teams walk the full length of that dry, lit, finished tunnel for the first time, they will be standing inside something that took the combined will of two nations, the technical mastery of engineers from across the continent, and billions of euros of investment to create. They will be standing inside the proof that infrastructure on this scale is still possible, that the age of great construction is not behind us. It is, right now, happening beneath the Baltic.